Ever get that feeling, when you're binging some sci-fi show and time travel gets thrown in? You get that, like, whoa, hold on.
Yeah.
Could that actually happen?
Right.
That's what this deep dive is all about.
Absolutely.
Separating the science fact from the science fiction of time travel.
It's a good one.
We've got some wild, fascinating snippets from a paper that breaks down, like, the real science behind time travel.
Yeah.
And
I'm excited.
oh, trust me, some of this stuff is going to make your head spin.
It's true.
Okay. It's true. So listeners, buckle up, right?
Okay.
Einstein's theory of relativity.
Here we go.
It's not just about
It's a big one.
EMC code, although that's very cool.
That's pretty cool.
But it's about how time itself is not a constant.
Exactly.
It's not the same for everybody everywhere.
And one of the most incredible implications of that is time dilation.
Okay.
And the really wild part, time dilation isn't just some theoretical physics.
Right.
It's been scientifically proven.
Proven?
Yeah.
No way.
Yeah.
Tell me more.
So think about, like, astronauts up on the International Space Station right now.
Okay, yeah.
They're actually aging a tiny bit slower than us Earth dwellers.
Yeah.
Because get out. Zipping around the planet so fast.
Seriously.
That's true.
So astronauts are, like, basically time travelers.
In a way, yeah.
That's amazing.
Right. I mean, it's real.
It's a real effect. It's just at those speeds, it's super, super small.
Yeah.
But it's measurable.
Okay.
But then imagine, like, near a black hole.
Oh, yeah.
Where gravity is, insanely strong flame
Right.
dilation, it would be much more intense there.
Wow.
Yeah. Almost like hitting, like, a fast-forward button.
Hold on. So, so you're telling me that black holes, like, potentially could be used to travel to the future?
Yeah, you could theoretically use that. That's straight out of a movie.
It's a mind-blowing concept, isn't it?
It is.
Of course, actually getting close to a black hole presents, shall we say, some challenges.
Yeah, just a couple.
Just a couple, yeah.
Yeah, I can only imagine. Okay, so travel into the future.
Yeah.
Even if it's not, not quite like Back to the Future.
Right.
It's theoretically possible.
Right.
Right?
Mm-hmm.
We could, like, speed ahead a little bit.
Yeah.
What about going back in time?
Yeah, that's got to be...
That's where things get really tricky.
That's got to be a lot harder, right?
Right, it is.
Right.
Going back in time.
Yeah. That's
where we really leave the realm of what's definitively possible.
Okay.
And kind of dive headfirst into speculation,
Yeah.
Instead of time dilation, we're talking about things like wormholes.
Okay.
And closed time-like curves.
Wormholes.
Yeah.
Those are like the shortcuts through space and time, right?
Precisely.
Yep. Yeah. So imagine, like, folding a piece of paper in half.
Okay.
And poking a hole through it.
Right.
And that's kind of a simplified way to picture a wormhole, right?
Okay.
Connecting these two distant points in space-time.
Okay. So with a wormhole, you could theoretically travel, like, vast distances across the universe.
Across the universe, yeah.
Or even, like, jump to a different point in time.
It's wild, right?
That's crazy. I mean, is that even something...
That's a great question.
...that could actually exist? Like, is that real?
Yeah. So theoretically, maybe
Yeah.
Einstein's general theory of relativity suggests that they are possible.
Okay.
But creating one,
right,
let alone, like, stabilizing it for travel,
right,
that's a whole nother can of cosmic worms.
I bet. That's a whole other level.
Okay.
And then you got these closed time-like curves. That sounds
It's a lot to unpack.
What are those? Okay.
So picture like a loop in space-time.
Okay.
A path that, like, folds back on itself.
Oh,
right.
Okay.
So that's a closed time-like curve.
Okay.
Essentially, it's a path that could, in theory, allow for backward time travel.
Okay, so, like, you're telling me, with these closed time-like curves, you could end up...
You could,
back where you started, but in the past?
Potentially, yeah.
Like a time loop?
Yeah, exactly. Think of it like this. If you were walking along a closed time-like curve, right, and you just kept walking forward, you wouldn't just be moving through space.
Okay.
You'd also be moving backward in time.
Oh, wow.
And eventually, you'd return to the same point in space-time.
Wow.
Where you started your journey.
That is wild.
Right.
But wouldn't messing around with time like that,
Well, yeah, I mean,
like going back and maybe like, I don't know, changing something. Wouldn't that like create some major paradoxes?
Absolutely.
Right.
Like what about the
grandfather paradox?
Yeah. Like that's
a classic example of kind of the potential problems with backward time travel.
Yeah, right. Right.
Imagine like going back in time
Yeah.
and accidentally preventing your own birth.
Right.
It makes your brain hurt.
It does.
Trying to wrap your head around it.
It really does.
Yeah.
And that's just like one example of a paradox.
Right. And there are tons.
There's others.
Oh, yeah. There's there's the bootstrap paradox.
Okay.
So imagine you find a copy of your favorite book.
Okay.
Right.
Okay.
You go back in time.
Okay.
You give it to the author before they wrote it.
They copy it. They publish it as their own.
Right.
Where did the book originate?
Wow.
We've created a causal loop.
Wow.
Right.
So it seems like going back in time.
Yeah.
Even if it were possible, could really mess things up.
Yeah, it's a mind-boggling concept.
Yeah.
With, potentially like universe-altering consequences,
Right.
So it really makes you appreciate why a lot of physicists believe that these closed time-like curves are probably not possible.
Right.
At least not in the way that we imagine.
Okay, so we've got time dilation, which is like a scientifically proven form of time travel to the future.
Right, yeah.
But it sounds like going back in time.
That's a lot.
With wormholes or closed time-like curves. It's still purely theoretical.
It is, yeah. For now, at least. Oh. Yeah, our current understanding of physics suggests that backward time travel is likely impossible.
Right. Yeah.
But who knows?
Right.
Maybe someday we'll discover something that turns our current understanding of the universe on its head.
I like the way you think.
You know?
Like you said earlier.
Yeah.
What's so exciting about science?
It's true.
Is that there's always more to learn.
Always.
That's crazy, Yeah. There's so much about this stuff.
It's true.
That we just don't know.
We don't.
Oh.
Yeah.
Yeah.
It's incredible to think about what we might discover.
Absolutely.
In the future,
Yeah, yeah.
But for now,
that's exciting.
I guess the dream of like hopping in a time machine and going back and seeing ancient Rome.
Yeah.
That's staying in the realm of like fantasy, right? Yeah. For now, it seems that way.
Yeah.
At least for traveling into the past, right?
Yeah.
Don't forget. Yeah. Time dilation is real.
That's true.
Yeah.
Right.
And who knows what advancements the future holds.
Right.
For
for manipulating it even more.
Manipulating it further. Exactly.
Yeah, that's true. Maybe we can't rewind time, right?
Right.
But who's to say we won't find ways to fast forward even more dramatically, right?
Exactly.
Okay, last one for you. Thought experiment.
Okay,
so if we could send a message back in time.
Okay.
Right. Not travel ourselves.
Right.
But just like send a message.
Oh, okay.
What would it be?
Wow, that's
right.
I've never considered that.
It's a tough one, right?
Yeah.
Like what message?
It's a big question.
Could you possibly say that wouldn't risk unraveling the fabric of space-time?
Right.
Right?
Right.
Like, is it a warning?
Right. Yeah.
Is it like, hey, something bad's gonna happen?
Right. Like, are you trying to change things? Are you just trying to say hello?
Or just like, hey, what's up?
Yeah.
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 That's a good question.
To like someone from history.
Each one of those scenarios opens up a Pandora's box of consequences.
Right. It's like it's one thing to
It's a fantastic thought experiment though.
Right.
It really is.
It's one thing to imagine us traveling, right? But sending a message is like a whole other
it adds a whole other layer to it.
Yeah. What would you say to your past self?
To my past self.
Right.
Knowing what I know now.
Knowing what you know now. That's a tough one.
Right.
I think maybe just a gentle nudge, to embrace curiosity.
Okay.
And never stop questioning.
I like it.
Yeah.
I like it.
A little message of encouragement.
Message of encouragement.
A little wonder for a younger me.
I like it. This deep dive has been a wild ride.
It has been fun.
I've had a blast.
It's a good one.
It's definitely made me look at time in a whole new way.
As it should.
It really has, yeah.
Time is one of the most fundamental aspects
That's true.
of our existence, yet it remains
one
of the most mysterious.
Well said. Well said.
You know?
A big thanks to you.
Of course.
For joining us.
Happy to be here.
On this journey through the science and speculation and time travel. And to all of our amazing listeners out there.
Yes.
Until next time, keep exploring the universe.
Yes.
And never stop asking. What if?